Investigation of Curves, Section 4, Envelopes and Arc Lengths. Video 5, Finding Equations of Envelopes. In the previous video, we saw that to find the equation of an envelope, we can start by writing the equation of the family of curves in the form of f of x, y and p equals 0, where p is a parameter, find the partial derivative, and then eliminate p from the equations f of x, y and p equals 0 and partial df by dp equals 0. Let's work through an example to see how we would do this in practice. So here's the question. Find the envelope of the lines that pass through the points A0 and 0, 1 over A. Well, let's start by seeing what this looks like. I need to start by plotting the point A0. And it asks me to create a slider for A. And then I can plot the point 0 and 1 over A. And there's my second point. So I'm going to draw a line that joins those 2 points. And then I'm going to use the trace function. So I right click on the line and turn the trace on. And then as I move my slider for A, it draws all of the different lines. And you can start to see the envelope starting to form. And if we look at the shape of it, it looks as if it might be a rectangular hyperbola. So how will we prove that it is in fact a hyperbola? Well, first of all, we need to find the equation of the family of straight lines. So we need to work out the gradient, which is going to be the change in y divided by the change in x. So gradient equals, and then a goes from 1 over a to 0, so that's a change of 1 over a, divided by, and from 0 to a, that's minus a. So I divide those and I get minus 1 over a squared as my gradient. So to find my function then, I will have y minus y1 equals mx minus x1. So y minus 0, that's just y, equals m, so that's my 1 over a squared, x minus x1. So that's just a. And so tidying that up a little bit, I can rearrange and get a squared y equals minus x plus a, multiplying through by a squared. And then finally, I want this so that I've got everything on the left and 0 on the right, and I'm going to use p as my parameter. So I get x plus p squared y plus p equals 0. So now, as I need to, I've got it in the form of f of x, y and p equal to 0. Now I need to work out the partial derivative. So df by dp, I need to differentiate with respect to p, treating x and y as they are constants. So the x is going to disappear because it's a constant. My p squared y becomes 2py, and then the p just differentiates, give 1. Actually, this should have been minus p up here, so it's minus 1. I'll just change that to a minus p instead of a p. There we are. Okay, so in order to solve this, I need to find where 2py minus 1 equals 0 and where x plus p squared y minus p equals 0. Let's use the computer algebra system for this. So I start by putting in x plus p squared times y minus p, and that's my expression. And now I need to find the derivative of expression 1 with respect to p, and that gives me my partial derivative 2py minus 1. And now I want to solve when that derivative is equal to 0, so expression 2 equals to 0, and I want to solve for p, and that gives me p equals 1 over 2y. And finally, I want to substitute that into expression 1. And so I'm substituting in expression 3. And that gives me 4xy minus 1 over 4y. And I need to know when that is equal to 0. So solve expression 4 equal to 0. Solve it for y. And I get the equation y equals 1 over 4x. So going back to my graphics window then, let's plot what y equals 1 over 4x looks like here. So I put in y equals 1 over 4 times x. Put that in brackets like that. And there we have it. So if I move my slider now, we can see that that green line is in fact the envelope for my set of lines there. So let's finish this off. I need to write down that for my envelope I've got that f equals 0 and partial df by dp equals 0. And when that is true, I know that y equals 1 over 4x. So y equals 1 over 4x is the envelope of the lines that pass through A0 and 0, 1 over A. In this video, you learned how to find the envelope of a family of curves.